Welcome to day 4 of Jamb Mathematics in 30 days. If you have been following the series so far, I hope you're enjoying it, and keep your questions coming. Anything you want us to solve as far as the syllabus of Jamb in this year is, please put them in the comment section and we'll attend to them all. So for day 4, we are going to be looking at set, and what Jamb expects of you as students to know before you go into the exams concerning set as follows. Firstly, you are to be able to identify types of set, that is empty set, universal set, complement, subset, finite, and disjoint set. You're also expected to be able to solve problems involving cardinality of set. Thirdly, you should be able to solve set problems using symbols, because many of the questions you will solve would come with symbols. You should be able to identify those symbols, interpret them, and use them to solve problems on set theory. And then finally, you should be able to use Venn diagrams to solve problems involving not more than 3 sets. So it will not exceed 3. You can do 1, 2, and then 3 sets, represent them in Venn diagrams, and solve problems involving set with them. Now let us look at some questions that have been set in the past on set. Now, this question says a group of market women sell at least one of yam, plantain, and maize. Now 12 of them sell maize, 10 sell yam, and 14 sell plantain. 5 sell plantain and maize, 4 sell yam and maize, and then 2 sell yam and plantain only. I'll get back to this part where we have 2 sell plantain, yam and plantain only. And then 3 sell all 3 items. So we are asked how many women are in the group. So that is, we have to find the universal set. So to solve this, you can draw a Venn diagram. So we're looking for the universal set. Now in here, we're going to have 3 circles that will loop into each other, like so. So let's call this maize, then yam, then plantain. We know that those who sell maize are 12. Now of these 12, some of them will sell yam, some of them will sell plantain. So that is why we can't write it into this circle yet, so we just put it out here. Now for yam, we have 10, and the same goes for plantain, which is 14. Now, let's start from this, where we have 3 sell all the 3 items. Now, we have to look for the points where all 3 circles are going to loop into each other. Now, when you consider this part, you see that the yam loops around this. The circle for plantain loops around it as well, just as the circle for maize loops around this. So this part is where we have all 3 items, right? So we put 3 there. Now, this part says 2 sell yam and plantain only. That is, we have to look for the part that only consists of the circle for yam and the circle for plantain. Now, looking at this circle for yam and this circle for plantain, you see that this point only joins yam and plantain together. So that will be the point where we put 2. Now, we are told that 5 sell plantain and maize. So when we look at the circle for plantain and the circle for maize, we see that this is the point that joins plantain and maize. Now 5 is the number that should be here. Of that 5, we already have 3. So what is left will be 2. So when you consider this, 2 plus 3 gives you the 5 that we have here. Now 4 sell yam and maize. So this is the circle for maize. This is the circle for yam. So this part here is where we have maize and yam, right? And the number of women that sell yam and maize are 4. So of that 4, 3 already sell plantain as well. So what is left is 1. 4 minus 3, that gives us this 1 here. Now we can then go on to fill in the remaining part here. Now the good thing is that we are told that there is no woman that that is in this group that does not sell any of these three. So none is outside here. So if altogether we have 12 of them selling maize, that is, the circle for maize should have 12 in it. So if we're going to put 12 here, out of that 12 we already have 1, 3, and 2 that add up to 6. That is, what will be left is 12 minus 6, so we have 6 here. Now 10 sell yam. So for this circle for yam, we already have 1, 3, and 2, which makes up 6. So 10 minus 6, and we have 4. That is, 4 are selling yam alone, just as 6 is selling maize alone. Now for plantain, we're told that 14 sell plantain. So out of that 14, we already have 2 here, 3 here, and 2 here, which when we add together, we get 7. So 14 minus 7, and we have 7. So this is the complete Venn diagram. Now, let's find the universal set. That will be the addition of all the numbers within all the circles that we have here. So we'll be having 6 plus 1 plus 4 plus 2 plus 3 plus 2 plus 7. So the universal set is therefore, now 6 plus 1, that's 7. 7 plus 4, we have 11. 11 plus 2, that's 13. 13 plus 3, and that's 16. 16 plus 2 is 18. And then 18 plus 7. This would give us 25. So we have 25 women in the group. So the correct option here would be option A. This question says, let P be this set Q. We have the set of Q here and then the set of R as follows. So P is represented by 1, 2, U, V, W, and X. That's the subset of P. The subset of Q are 2, 3, U, V, W, 5, 6, and Y. And then the subset for R are 2, 3, 4, V, X, and Y. So we are asked to determine P minus Q intersect R. Now, when you see this symbol here, a particular set minus another set, what it means is you have to look at for the subset of the first set that is mentioned here. You look out for those subsets that it has but is not present in the second set. That is, what does P have that Q does not have? So, solution. First, to get our P minus Q. Now, considering the set P and set Q, you see that we have 1 here in P and Q does not have 1. So we have this 1, comma, 2 is present in both. Now U is present in both, V is present in both, W is present in both. So what we have left is X. So P minus Q will give us 1 and X. Now, P minus Q intersect R means, what does this new set that we have created have in common with R? So when we consider these two sets, you find that the only thing they have in common is X. Therefore, the correct answer in the options here is option C. This question says, in a youth club with 94 members, 60 like modern music and 50 like traditional music. The number of members who like both traditional and modern music is 3 times those who do not like any type of music. So, how many members like only one type of music? Now, to solve this, let's have a Venn diagram to simplify what we have here. So, we're only going to have 2 loops. Now, let this be modern music and this be traditional music. Now, we are told that 60 like modern music, so M here will be 60, while T for traditional will be represented by 50. We know our universal set is 94. Now, when you look at this line, we're told the number of members who like both traditional and modern music is 3 times those who do not like any type of music. That tells us that there are some members that do not like music at all. So if that is X, let's put that here. That is, those that love both modern and traditional will be 3 times of this. So we'll call this 3X. Now, the numbers of those that will like only modern music would therefore be 60 minus 3x. And for traditional, it will be 50 minus 3x. Now we have a complete Venn diagram. So let's solve. To find the value of x, we have to add everything within this set and equate it to 94. That is 60 minus 3x plus 3x plus 50 minus 3x plus x all give us 94. Now 60 plus 50 would give us 110. Minus 3x plus 3x, that's 0. Now minus 3x plus x will give us minus 2x, and this equals 94. Now take this to the other side, and then we have 2x equals 110 minus 94. So 2x therefore becomes, now the difference here is 16. So x becomes 16 divided by 2, which is 8. So now that we know x, that is 3x will therefore be 3 times 8, which is 24. Now, the question itself says, how many members like only one type of music? That is, those that like only modern plus those that like only traditional. So that is, we're going to be having 60 minus 3x plus 50 minus 3x. So this is 60 minus, we solved for 3x already to be 24, then plus 50 minus 24. Now when we tidy this up, 60 plus 50 is 110 minus 24, that will give us 48. Now let's find the difference here. So that will be 62. So we have 62 members that like only one type of music. So the correct option will be option C. This question says, if x is given as n squared plus 1 such that n is 0, 2, and 3, and then y has a set of n plus 1 such that n is 2, 3, and 5. Now find x intersect y. Now to solve this, we have to bring out the subsets of x and y respectively. So x would therefore be, now remember that n ranges from 0, 2, and 3. They are just 3 values of n, 0, 2, and 3. And we're going to apply this. Now when n is 0, 0 squared will give you 0. So plus 1, so we'll have 1. Now when n is 2, that will be 2 squared, which will be 4, plus 1, and then we have 5. And then when n is 3, so 3 squared is 9. And then 9 plus 1, and then we have 10. Now, y. Y has values of n plus 1 such that n is 2, 3, and 5. So when n is 2, we would have 2 plus 1, which would be 3. When n is 3, that will be 3 plus 1, that is 4. And when n is 5, that will be 5 plus 1, so we would have 6. So these are the subsets here of x and of y. So x intersect y is what we have to find now. Now do not forget to like, share, and subscribe. Share this to as many who are preparing for Jamb this year. let all pass in flying colors. Now, when you look at the subset of x and y here, you find that they do not have anything in common. And intersect tells us that we should look for what they have in common. So since they have nothing in common, we'll say that x intersects y is a null set. So the answer is C. This question says, if x is a set such that its subsets are represented by n squared plus 1, where n is a positive integer and 1 is less or equal to n, less or equals to 5. That is, the values of n ranges from 1 to 5, from 1 to 5. And then y is represented by 5n, where n is also a positive integer that ranges from 1 to 5. Now let's find x intersect y. Solution. Now we have to write out the subset of x and y so that we can then compare. So for x, we'll be having, now take note, remember we said n is from 1 to 5. So you do for when n is 1, 2, 3, 4, and 5. So when n is 1, we'll have 1 squared. That will give you 1, plus 1, and then we have 2. Now when n is 2, that will be 2 squared to give us 4, plus 1, and then we have 5. When n is 3, 3 squared will give 9, 9 plus 1, and that is 10. When n is 4, 4 squared will give us 16, and then 16 plus 1, 17. And then when n is 5, so 5 squared is 25, and then 25 plus 1 would give us 26. So these are the subsets of x. Now let's find the subsets of y. So we'll apply the same thing, but this time for 5n, where n ranges from 1 to 5. So when n is 1, we'll just have 5 times 1, which will give us 5. When n is 2, that will be 5 times 2, that's 10. When n is 3, we'll have 5 times 3, which is 15. When n is 4, to be 5 times 4, 5 times 4 is 20. And then when n is 5, to be 5 times 5 to give us 25. So now we have the subsets for x and y. So let's then do x intersect y. That is what x and y have in common. Now considering these two subsets, we can see they have 5 in common and 10. They do not have any other thing in common. So x intersect y is therefore 5, 10. And the option that has 5 and 10 only is option A, which will be the correct option. In this question, we are given 3 statements. Statement 1 says S intersect T intersect W equals S. Statement 2, S union T union W equals W. And then statement 3 says T intersects W equals S. Now the condition is if S is a subset of T, which is also a subset of W. Now whenever you see this symbol, it tells you subset. So S is subset of T, just as T is subset of W. So which of these above statements are true? Now to put this into perspective, what it means is that everything that you have in S, you will find it in T. And everything you have in T, you will find it in W. It's like saying W is the grandfather to this generation. So S being the child, T being the father of S, and then W being the father of T, that is the grandfather of S. That's just one way to put it. But let's put it in another form so that you get it right. So if we say, for example, S is, say, 1, 2, and 3. We can then go on to say T would be, now everything that you have in S, which is 1, 2, and 3, plus other things. So let's add 4 and 5 to this. Then we can then go on to say W would then be, now everything you have in T, which is 1, 2, 3, 4, 5, and then more. So let's just say 6. So this is just what the statement is saying. In this case, you see that S is a subset of T, which is also a subset of W. Now let's test these ones and see whether it is true. S intersect T intersect W would be what? Now, using this that I've given here, we are going to look at what S, T, and W have in common. So the three sets all have 1, 2, and 3. That's the only things they have in common. 1, 2, and 3. Those are the only three things they have in common. And you see that 1, 2, and 3 are the subset of S. Therefore, we can say that S intersect T intersect W is S. So this statement is true. Now the second statement, S union T union W. Now recall that in set we do not repeat numbers. So when we consider S, T, and U and we combine all their elements together, what are we going to have? So remember, we do not repeat elements. So we'll have 1, 2, 3, then 4, 5, and 6. That's everything combined. You cannot repeat any one of them. So, and if you consider 1, 2, 3, 4, 5, and 6, you see that they are all the elements that you will find in subset W here. So we can say this is W. Therefore, S union T union W is W. So the second statement is also true. Now the third and final statement here says T intersect W. Now let's look at subset T and subset W and see the elements that they have in common since we are doing intersection. So the intersect of T and W would be all the elements in T, which is 1, 2, 3, 4, and 5. Now this is actually T and it's not S. Therefore, T intersect W intersect S is false. So the statements that are true there is statement 1 and statement 2. So our answer would be A. So this question says, in a survey of 50 newspaper readers, 40 read Champion and 30 read Guardian. Now, how many read both? That is, we have to find the number of people that read both Champion and Guardian. So we know that our universal set is supposed to be numbers of those that read Champion plus numbers of those that read Guardian minus numbers of those that read both. So that is Champion intersect Guardian. So we can say let numbers of Champion intersect Guardian equals X. Then we use this to solve. Universal set says we have 50. So 50 equals, now number of those that read Champion is 40 plus number of those that read Guardian is 30, then minus numbers of Champion intersect Guardian, that is X. So 50 would then be equals to 70 minus X, which implies that X equals 70 minus 50. And 70 minus 50 gives us 20. So the correct option is option D. Now in this question, we are given a Venn diagram and we have subsets Y, Z, and X. And we have this portion shaded. So we are told the shaded portion in the Venn diagram is, that is, which of these options tells us of the shaded portion in this Venn diagram. Now, when you consider the portion that is shaded, you see that that portion is found in the loop of X just as much as it is found in the loop for Z. Now, don't be quick to say it is X intersect Z. You still have to look carefully. Now, when you look at this circle for y here, you see that y is not at all part of this shaded portion. So that is, we have to take out y from what we have here. So what you will see is that we have x there, and that's something in common with z, but nothing in common with y. So that will be x intersect y complement intersect z. So the correct option is going to be the option C. Here's another Venn diagram, and we are asked to identify the shaded portion in the Venn diagram. Right? So identify what that shaded portion represents. So in this Venn diagram, we see E, F, and G looping into each other. So E loops with F, and then G also loops with F. But there's no connection between E and G. Now, when we look at this, you see that the shaded portion we have here is found in the circle for F. Now, when we trace out the circle for G, we see it has nothing at all to do with what is shaded. And then when we do the same thing for E, we see it has nothing to do with the shaded portion. So as a result, we are looking at E complement and G complement. So that is why the answer would be E complement intersect F intersect G complement. And the option that carries this is option B. This question says, if the numbers of P is 20, number of Q is 30, and number of P union Q is 40. Find the value of the numbers of P intersect Q. So we see here that there are two subsets, P and Q. So we have to find what they have in common. Now, when we have two subsets like that, we know that the universal set should be numbers of the first one plus numbers of the second minus what they have in common, which is numbers of P intersect Q. So the universal set is where we have numbers of P union Q. So that is, we have 40 here equals number of P, that is 20, plus number of Q, that is 30, minus number of P intersect Q. Now, working with this, we would have 40 equals 20 plus 30 would give 50 minus numbers of P intersect Q. So we take this to the other side and bring 40 here. So numbers of P intersect Q would then be 50. Now, when plus 40 crosses the equality sign, it becomes minus 40. So numbers of P intersect Q is therefore 50 minus 40, which gives us 10. And the option with 10 is A. So the correct answer is option A. Please do well to like, share, and subscribe to content on this channel. Share it with your friends so that they too can improve on their mathematics skills and also score high grades in Jamb this year.